Welcome to Dr. Balaga's God Knowledge Doc podcast, your quick dive into the latest medical breakthroughs to keep you ahead of the curve. Let's get started. Today is October 13, 2025. This video is in a Science magazine article published on October 9, 2025, titled T-cell cholesterol transport links intestinal immune responses to dietary lipid absorption. There's an accompanying perspective titled A Tripartite Alliance for Dietary Fat Absorption. Cholesterol is essential for immune cell membrane homeostasis and signaling. Aster-A is a cholesterol transporter expressed in T helper 17 cells, regulating plasma membrane cholesterol. The study links T-cell cholesterol control to intestinal fat absorption and systemic metabolism. The investigators used mouse models, liver-specific, intestine-specific, and T-cell-specific CD4 knockouts of global Aster-A. Sample size 10 to 30 mice per group. Duration 2 hours to 10 weeks. To a high-fat diet exposure. Measurements, radio-labeled trial in uptake, flow cytometry, RNA-seq confocal microscopy, statistics, ANOVA, t-test, and p-values. What did they find? That fat absorption decreased in Aster-A deficient mice. They showed a decrease in trial in uptake in the intestine, heart, and liver, p-value 0.01, less than 0.01. Obesity resistance, a delta CD4 mice resisted weight gain in high-fat diet, p-value 0.001. T helper cell 17 hyperactivation resulted in increased plasma membrane cholesterol, an increased TCR receptor signaling, and an increase in IL-17 and IL-22. IL-22 in turn affected fat malabsorption. IL-22 suppressed absorption, blocking it restored it. Limitations: limited to murine models, human relevance pending. Cholesterol effects are specific to fatty acids. Key takeaways: Aster-A links T-cell cholesterol sensing to lipid metabolism. IL-22 drives fat absorption. Immunometabolic crosstalk offers therapeutic potential. The accompanying perspective summarizes this: fat absorption regulated by a tripartite axis of T helper 17 cells, cytokines, notably IL-22 and enterocytes. Loss of Aster-A in T cells increases membrane cholesterol, boosting T-cell receptor signaling and IL-22 secretion. IL-22 suppresses enterocyte triglyceride uptake, linking immune activity to nutrient flux regulation. This immunometabolic feedback may protect against dietary excess but remains unvalidated in humans. Key takeaway: nutrient absorption is actively shaped by immune signaling, offering new targets for metabolic disease intervention. Some related eponyms: Peyer's patches, Johann Conrad Peyer, 1653 to 1712. Lymphoid follicles in the ileum, crucial for mucosal immunity. Brunner's glands, Johann Conrad Brunner, 1653 to 1727. Duodenal glands secreting protective mucus and bicarbonate. Paneth cells, Joseph Paneth, 1857 to 1890. Antimicrobial epithelial cells at the base of the intestinal crypts. Kupffer cells, Carl Wilhelm von Kupffer, 1829 to 1902. Liver-resident macrophages regulating gut-derived metabolites. MALT, mucosa-associated lymphoid tissue, coined in the 1970s, key to gut immune surveillance. There's no personal eponym. If you enjoyed this episode, share it with your colleagues. When we change how we see disease, we change how we shape lives. Until next time, stay curious, stay compassionate, and keep seeking wisdom. Podcast brought to you by masterbedfacts.com. This podcast is for physicians and healthcare providers. If you enjoyed this video, please like, subscribe, and forward to your friends.